We will be discussing again one of assumptions that needs to be considered when we are using regression. So I'm teacher Melai and let's talk about Durbin-Watson Statistics. What is Durbin-Watson Statistics? It is used to measure autocorrelation. So it measures the correlation between each residual and the residual for the previous time period. So this is one of the basic assumptions of the regression model, which is the independence of errors. This assumption is sometimes violated when data are collected over a sequential time period because a residual at any one time period may tend to be similar to residual at adjacent time period. So this is the formula of our Durbin-Watson statistic. So as you can see here, what we need to consider is the residual. So just to recall what is the residual. So in our previous discussion, we were able to compute for the residual by generating what is the formula or the simple linear regression and then also determining what is the predicted value. So it's the difference between the actual data and the predicted value. So here, the formula for the numerator, so we will start with the second data. So it's where I is equal to 2 until n. So the residual less the residual of the previous data. So it's I minus 1. So we have to get the square and then divide it to the summation of the square of the residual starting in I is equal to 1 until to n. So E sub I is the residual at the time period I. And after determining for that or generating for the value, what we need to look at is whether it is autocorrelated or not autocorrelated. So we have here the guide that if D will approach to 0, if successive residuals are positively correlated. So if the residuals are not correlated, the value of D will be close to 2. So if the residuals are negatively autocorrelated, they will be greater than 2 and could even approach its maximum value of 4. Okay, so let us do this using our Microsoft Excel. So we will use the same data. So this is the same data for sales. If you still recall this data in our previous video. So we have the size and the sales. Okay, so we will use data analysis. We will generate our regression. Again, data analysis, regression, and click OK. And of course, you have to place the input Y. That's our sales. And then for input X, the size. So it's already placed here. So we have here the input X. It corresponds to the value of our values in this column. And then what we need, so in our previous video, we actually check all of these items, normality, residual plots, align fit, normality, probability plots, for us to check for the assumptions or for the conditions that we need to consider before using the simple linear regression. So right now, what we need to do is just to check residual and then click OK. So this is now the result. But of course, we're not going to consider the first few parts because our concern is this part, residual. So what we will do is to copy the residuals and place it in a separate, in another sheet. So let us compute. So I'll place it here so that it will be placed at the center. So this will be the residual. So what we need to do is For us to compute the numerator, so let us go back to our formula. So what is our formula? So this is the formula. So we are going to follow this formula. So the residual will be copied so that it would be easy for us to deduct is a I minus the 1 and then remove this last part. Anyway, it is stated here that we are going to start in the I is equal to 2 and this is I is equal to 2 because this is the value for E is a 1. Okay, so let's deduct this. We will just get the difference. So F3 less this value and then get the square. No, we don't need to get the square first. We have to get the summation. Anyway, we can actually get the square before getting the summation because it is the summation of the square. So let us raise this to 2. Okay, so let's just make it larger so that you can see. So again, the formula that we placed is just the difference between this residual minus the previous residual and then raised to 2. So equal sign, open parenthesis, and then the difference, just select it. And then raised to 2 is this one, raised to 2. Then click OK. So we will just drag this and get the sum because it's summation. So aside from placing the formula, you can also use the function AutoSum. So home AutoSum, enter. So this is the sum. And then the next one is to get the square of this value. So raise to itself. Sorry. Multiplied by itself. And then get the summation. AutoSum. Okay, so these are the values that we need. So this will be the numerator and this will be the denominator. So all we need to do is to divided by this one. So this is our Durbin-Watson value. So the Durbin-Watson value is 2.436302 as you can see here. So what to do is let's go back to our in our PowerPoint and let's see what it means if it is. So it's close to 2. So it is not correlated. So if the residuals are not correlated, the value of D will be close to 2. So it's not actually, if it's very near to 0, that's the time that we can say that it is autocorrelated. So our data is not correlated. So this is all for this video. Thank you for watching.